In this video, I want to talk about how to find the greatest common factor of two or more algebraic terms as a precursor to factoring algebraic expressions using the greatest common factor. Now, by the time most students get to Algebra 1, they usually have a pretty good intuitive sense of identifying the greatest common factor of two or three numbers. So we'll briefly hit this and then talk more about what it looks like to determine the greatest common factor of two terms that also include variables, which is pretty straightforward. So in this first example, let's just take a look at two numbers, 45 and 75, and we're asking ourselves, what's the greatest common factor here? Well, a lot of you can probably tell what that is just by looking at these numbers because you have good number sense skills. But if not, and you need to kind of work out something, let me show you a good way to do this. So I'm going to put the two numbers side by side, and I'm going to go ahead and divide out factors that are common. Well, I see that both numbers end in 5, so let's go ahead and factor a 5 out of both of them. So 45 divided by 5 is 9, and 75 divided by 5 is 15. Now you ask yourself, does 9 and 15 still have a factor that's in common? Well, sure. You can actually divide a 3 out of both of those. So 9 divided by 3 is 3. 15 divided by 3 is 5. Once again, is there a common factor between 3 and 5? Well, there's not. Okay, so what's the greatest common factor then? Well, it's all the numbers you divided out. So 5 times 3. So we'll say the greatest common factor is 3 times 5, which is 15. And when you divide 15 out of both of these numbers, you end up with 3 and 5. Okay, well, let's throw in a third number in the mix. So we have 45, 50, and 75. And we're going to kind of work the same process. So what number will come out of all three? Well, it looks like 5, so I'll have 9, 10, and 15. Now, is there a common factor between all three of these? Well, there's not. So just 5 is the greatest common factor when we add in the 50 in there as well. So again, probably you had a good intuitive sense of what these values were before having to show any work at all. But sometimes when you're working these problems out, it's okay on the side to work out the greatest common factor if you need to. Now let's go ahead and look at an example with just variables. I would like to know what the greatest common factor is between x to the 4th, x to the 6th, and x cubed. Well, maybe if you're not familiar with this using variables, it's not quite as obvious as with numbers. So let's go ahead and look at these all separately or a different way. Okay, so x to the 4th, when I write that in expanded form, it's really just 4x's being multiplied together. Similarly, with x to the 6th, it's just going to be 6x's multiplied together. And finally, with x cubed, it's just 3x's multiplied together. So when you're talking about what's the greatest common factor, you're asking yourself, what factor or factors do all of them have in common? And let's get them all together. Okay, well, they all have at least one x, and they all actually have at least another x, and they all have a third x, but that's kind of where it stops, isn't it? So what's the greatest common factor between these three terms that are all variables? Well, the greatest common factor is x cubed. Okay, so when looking at just the terms themselves, x to the 4th, x to the 6th, x cubed, all three terms include x's. So what we're really looking for is the smallest of those exponents, so x cubed. So 4, 6, and 3, 3 is the smallest. So the greatest common factor then of these three variable terms are going to be x cubed. And finally, putting this all together, here I have numbers with variables, and I would like to find the greatest common factor of these algebraic terms. So let's go ahead and consider the numbers first, and we'll consider those separately from the variables. So between 28, 35, and 21, what's the greatest common factor? Well, probably most of you said 7, right? Because 28 is 4 times 7, 35 is 5 times 7, and 21 is 3 times 7. And the leftovers, 4, 5, and 3, have no greatest common factor other than 1 between themselves. So I can say the greatest common factor as far as the numeric portion is going to be 7. Well, what about as far as the variables are concerned? Well, you'll see all three terms have the variable n, and the exponents are 5, 4, and 3. So what's the smallest of those numbers? Well, 3. So 7n cubed will be the greatest common factor between these three algebraic terms.